Welcome, everyone, and welcome to the 2020 CER Lunchtime Lectures, Humboldt, Science, and the Geography of Nature. Alexander von Humboldt is the focus of these lectures this year. He lived a long life. He had huge influence in the 19th century and beyond, and has lately been rediscovered in the context of earth science and environmental science and the focus on climate change and global impacts. For the Americas, he's important because of his famous scientific journey from 1799 to 1804 through the Americas, through South America, down into the Amazonian basin, along the Andes, Mexico, which was then New Spain, Cuba, and a stop in America on his way back to meet Thomas Jefferson and the intellectual elite of the United States at that time. He goes back to Paris and lives there for years, then ends up in Berlin, where he was born, all the while writing book after book that has huge impact in the early 19th century, and now are being rediscovered as they're retranslated into English. All of those books we'll explore this year as we move through the influence of Humboldt and his relevance to us today. We begin the year by looking at Western culture and the study of nature, looking at the background that Humboldt had to do the work that he did in the early 19th century. We'll then look at Humboldt's life in itself and the influence that he had in his own time and then in the years afterwards in the 19th century, going into the 20th. And then we'll bring Humboldt up to the 21st century. Humboldt and the Geography of Nature will be 3 lectures that put him in contemporary context and see his relevance in our own time of change and global understanding. But we're beginning the year by looking at the background that Humboldt had. And that background was rooted in a practice called natural philosophy that I talked about in the last lecture in January. Natural philosophy and the study of nature was the study of nature, the practice that Aristotle initiated and through 2,000 years moved forward into Humboldt's time. Humboldt considered himself a natural philosopher. There was not such a thing as science or scientist until just after Humboldt. But Humboldt also considered himself a naturalist, someone who practiced natural history, which was a parallel study to natural philosophy that we'll focus on today. Natural history as a practice culminates in the taxonomy of nature that emerges during Humboldt's time and then culminates in the science of biology. In March and April, we'll look at other aspects that predated Humboldt and that shaped his worldview and his practice of science. But today what we want to do is look at natural history and the taxonomy of nature. We want to go back to Aristotle again like we did last month and look at the parallel thing that Aristotle initiated, the study of natural history as differentiated from the study of natural philosophy and its practice. Both of them aim to understand order and change in the natural world. Starting with Aristotle up to the 19th century, natural philosophy was the common term for the practice broadly of studying nature, physica, the physical universe, that was dominant before the development of modern science. Modern science, as we understand it, only emerged during Humboldt's lifetime in the early 19th century, and really just after that, these different sciences that we know are differentiated. Natural philosophy, then, as I talked about last month, is reasoning and explanations about nature, as opposed to natural history, which was more qualitative and descriptive as a study of nature, looking at the particulars themselves. Natural history, the term itself, emerges from that writing of Aristotle and others that is an investigation or a research of those particulars. Rather than what our word history means today, these were books of Aristotle and others' nature research titled Natural History. Natural history, as we understand it, and as Humboldt practiced it, was really an invention of the Renaissance. And it's that transformation of natural history from Aristotle's time into the Renaissance, and then the scientific revolution that transforms natural history into biology, that we'll talk about through this lecture. And at the core of it is what Brian Ogilvy, identifies in his book, The Science of Describing. Because in the Renaissance, description becomes a central problem. Description as a central problem marks Renaissance natural history off from its medieval predecessors and then its 17th century successors. Ogilvy's argument is something that we'll unpack through this talk, and we'll understand that in the context of its Greek beginnings and then what comes after with Humboldt's time. So this movement from Aristotle to Humboldt is a process of focusing on observation and description as a practice of studying nature. Its collection in encyclopedias of knowledge, both in Greek and Roman times and moving forward into the Middle Ages. And then the emergence of artists as naturalists, these depictions that you see here that become more realistic over time. And the collecting broadens out from the old world that Aristotle knew to the new worlds that are discovered post 1492, and then as Europeans encircle the globe, collecting all that time artifacts, plants and animals, and bringing them back to Europe to be understood, and that understanding taking the form of classification of these organisms and ultimately taxonomy, the sorting out of the organisms scientifically. When we go back to the Greeks, as we did last month, what we're doing is going back to the key figures of that time. And of course, Socrates underpins it all, but his student Plato and Plato's writings called the dialogues that we have to work with in understanding Socrates and Plato's philosophies. And of course, Plato is caricatured as the philosopher pointing towards the heavens, the place in the celestial realms where those things he called the forms exist. Aristotle was Plato's student and then Plato's successor with his own school called the Lyceum. And the Lyceum that Aristotle taught through was a school that was based on Plato's academy. And Plato's academy segued into Aristotle's school, and Aristotle as well ended up with students. This difference between the two of them, Plato pointing towards the heaven while Aristotle gestures to the earth, signifies that Aristotle saw empirical observation and actual experience of the sublunary world, the world below the heavens, as more important, builds the distinction between these two philosophers. But that distinction is much more complex than a gesture towards the heavens or the earth. At the core of it is Aristotle's approach to knowing nature, epistemology, the knowledge of nature, the sorting out for Aristotle of the many to understand the one. Whereas for Plato, the one is what we use to understand the many. It was that universal that exists apart from particulars for Plato that was more important. For that was the independent prototype, the eternal exemplar that helped us know the many, those particulars. What Aristotle attempts to do is to show how the one, the universal, emerges from particulars, does not exist apart from them. Aristotle found the universal in particular things, which he called the essence of things. And by applying the tool of logic, the organon for Aristotle looks at those many things, at those particulars, and allows us to recognize the universal that sorts them into kinds of things. So for Aristotle, therefore, logic implies the ascent from the study of particular phenomena to the knowledge of essences, induction. And this inductive process gives us a definition of a kind of thing. And at the center of that definition is the essence of that thing, the thing that sets it apart from other particulars. For instance, sets spiders apart from insects, because spiders have 8 legs, not 6. And that defining essence, then, we can use to deduce more scientific knowledge about the world. And the challenge with that is that the sublunary world is the mess of the many. How do you explain order emerging from all the change that unfolds around us? Things here have separate existence. They're individual particulars. But these particulars are very changeable. They're not like the eternals of the heavens, not like celestial objects that in Aristotle or Plato don't change. Down here, in the sublunary realm, things come into being. They grow, they mature, they decay, they die. Aristotle explained all that change through 4 elements: earth, water, air, and fire. All physical things are made up of 2 or more elements. Earth and water are heavy, so they tend to move downward. Air and fire are light, and they tend to move upward. And with this very simple classification of composition of things, Aristotle could explain motion, change, transformation through the sorting and exchange of these 4 elements. Now, when he turns to understanding order in nature, towards the classification of living things, he comes up with a first attempt at taxonomy. And taxonomy will become much more complex in the 17th century. But with Aristotle, it's the first attempt to sort living things out. And it's a fairly simple process that he goes through. He begins by looking at living things and sorting them into what we would call vertebrates and invertebrates, but what Aristotle calls animals with blood and animals without blood. The bloodless animals are insects and crustacea and mollusks. The blooded animals are organisms that bear live young or egg layers. And somehow in that mix, he has to fit humans, who are live-bearing creatures, but have a separate capacity to do this sorting out. So what he ends up with is the graded scale of perfection that gets called the chain of being or the ladder of life. And he places creatures on that ladder of life according to the complexity of structure and function. Higher organisms show greater vitality and the ability to move. And he ends up with 11 grades arranged according to the degree to which they are infected with potentiality, the ability to understand and the ability to be free in nature. And this freedom ranges from the ability to grow and reproduce to the ability to move about, and ultimately the ability to rationally think about the living world. So he ranked animals over plants based on their ability to move and sense. And then he graded the animals by their reproductive mode, right? Live birth being higher than laying cold eggs, the possession of blood, warm-blooded mammals and birds, again, being higher than bloodless invertebrates. And this graded scale of perfection gets called the great chain of being, rising from plants on up to humans at the top, since humans are the rational animals. A full account of the history of that idea is in Arthur Lovejoy's great book, The Great Chain of Being. And all the details of that history I can't begin to unpack in this one lecture. That book is the one I recommend go find. Now, Aristotle's most famous student who became his successor at the Lyceum is Theophrastus. And where Aristotle concentrated his natural history on animals, Theophrastus took up the challenge of sorting out plants. Theophrastus studied in Plato's school, and after Plato's death, he was Aristotle's student. And then Aristotle bequeathed Theophrastus all of Aristotle's writings and designated him as his successor at the Lyceum. What we get from Theophrastus, his own work focusing on plants, is divided into two collections, an inquiry into plants and on the causes of plants, which constitutes the most important contribution to botanical science during Greek period times and then through the Middle Ages. And it was the first systemization of the botanical world. The work on the causes of plants was originally 8 books, of which 6 survive. It concerns the growth of plants, influences on their fecundity, the proper times they should be sown and reaped, the methods of preparing the soil, manuring it, the use of tools, smells, tastes, properties of many types of plants. It was a horticultural work. But the inquiry into plants, originally 10 books, of which 9 survive, truly gives Theophrastus the claim to be the father of botany and plant taxonomy. Because this work arranged into a system whereby plants are classified according to their modes of generation, their localities, biogeography, their sizes, and according to their practical uses such as foods, juices, and herbs, linking it to his other work. Another of his innovations in this book was to classify plants using a hierarchical arrangement with an attention to defining characteristics based on their shape, their morphology, both internal and external form. So from this we get trees, shrubs, undershrubs, herbs, as well as an understanding of their life history, their mode of reproduction, their response to environmental factors. All of this leads him to be identified as that first father of plant taxonomy, and we'll look at how taxonomy gets transformed in the 16th, 17th, and 18th century, but it's that taxonomy of Theophrastus which dominates thinking about botany from his time through up into the Renaissance. The Romans inherited these ideas of natural history, both from Aristotle and Theophrastus, and all of it gets collected into the great encyclopedia of life that Pliny the Elder wrote, Natural History, Naturalis Historia, and this is more than just a look at plants and animals. It includes humans and human culture. It truly is the first great encyclopedia and becomes a model for all future natural histories and encyclopedia in terms of the breadth of subject matter examined, the need to reference original authors, and a comprehensive index of its contents. Natural history is one of the largest single works to have survived from the Roman Empire, and Pliny purports to cover the entire field of ancient knowledge based on the best authorities available. Pliny's library was vast, and he sat and he wrote up an account of what was in it. And so that account, because he attempts to be comprehensive with ancient knowledge, is both the actual things and the mythological and fantastical. And that inclusion of mythological and fantastical creatures and knowledge influences medieval accounts too. In terms of the actual, it encompasses the fields of botany, zoology, astronomy, geology, mineralogy, as well as the exploitation of those resources. My subject, Pliny wrote, is a barren one, the world of nature, or in other words, life. And that subject in its least elevated department, and employing either rustic terms or foreign, nay, barbarian words that actually have to be introduced with an apology. The barrenness here is it's not poetry, it's not philosophy, it's the world of nature. And one of the things that Pliny gives us as a gift is his inclusion of barbarian knowledge in words, foreign, rustic terms, not just the elite understanding of those things. Pliny's natural history is inclusive, and in that way, it's a huge cultural gift to the West. Paralleling Pliny's work is a more focused work on Roman medicine and plants, the pharmacopoeia, this application of, in particular, botanical knowledge to medicine. And for Roman medicine, at the core of that is actually a Greek physician who is employed by the Roman army, who is also a botanist by his practice, Dioscorides. And Dioscorides was a great attempt at including botanical and pharmacopoeial information into one great encyclopedia. He wrote in Greek, and this was translated into Latin. It was a 5-volume encyclopedia about herbal medicine and related medicinal substances, and it was widely read then for the next 1,500 years. At the core of our botanical writing is Dioscorides' great understanding of what existed in the old world carried forward in different forms. These 5 books were written around 77 AD. It focuses on around 1,000 simple drugs. It includes the description of nearly 600 plants, including the first description of cannabis, the poison water hemlock, the medicinal uses of peppermint, and it includes both actual and mythical and fantastical knowledge. The best example of this is Dioscorides' account of mandrake. The plant mandrake has aphrodisiac uses, and then it has the legend, because of the shape of its roots resembling humans, that it screams when pulled from the ground. So this combination of the actual with the mythical and fantastical is something we inherit from these Greek and Roman writers and their encyclopedias as well. In medieval natural history, then, you have this parallel between botanical and medicinal medical writings with the biological focus on animals. These herbals and the medicinal application of plants, one great representative of that is the medieval herbal that we inherit from Hildegard of Bingen, famous as well for her impact on choral music. But these works of hers on medicine and plants influenced a lot of the thinking during medieval time. Parallel to the work on plants is the work on beasts, and bestiaries then were these encyclopedias of known creatures that were both actual and mythical. Medieval bestiaries contain detailed descriptions and illustrations of species native to Western Europe, but also exotic animals from Africa and what in modern times are considered to be imaginary animals like unicorns. These descriptions of animals included the physical characteristics associated with the creature, although these were often physiologically incorrect. They weren't realistic. And they also included the Christian morality that the animal represented. So these cultural contexts for the animals were just as important as the physiological descriptions and depictions of them. So these bestiaries included both the actual and mythical. They were encyclopedias of animals. They included knowledge up to that time, and then they were put in a Christian context of morality. It was only in the Renaissance that we begin this transformation towards natural history as a more scientific discipline. And Renaissance naturalists then were unabashedly concerned with particulars in their description, and description as a way to grasp the beauty and diversity of the natural world. And in that, as Brian Ogilvy points out, you have a transformation of natural history from this acceptance of the fantastical and the moralistic into a more detailed focus on realistic descriptions and realism as the goal of natural history. So where in the Middle Ages you have herbals and medicine, in the Renaissance you have this focus on realistic description and the emergence of artists then as naturalists focused on realism as well. The groups that are doing this understood themselves to be a community of naturalists, not scientists, not just natural philosophers, but a group practicing something called natural history. Only, as Ogilvy says, only in the middle of the 16th century did naturalists come to think of themselves as practitioners of a discipline that, though related to medicine and natural philosophy, was distinct from both. No single individual invented natural history. By its very nature, it could be the product only of a community. And you can see how that sets the stage for science, which is a communal practice. Who were the figures in this emergence of Renaissance natural history? Well, one of the key figures that is a bridging figure from the bestiaries of medieval time to more realistic natural history of animals is Conrad Geisler. His 5-volume animal history that he published from 1551 to 1558 is that transitional work. It's the first zoological work that attempts to describe all the animals that were known at that time. It's the first complete bibliography of natural history writings as well. He showed the animals places in history, literature, and art. So very much like Pliny's natural history, here Geisler's attempting to do a complete description of all known animals and all the writings about them as well. But like Pliny and like the medievals, he included fantastical creatures like unicorns, but he also included newly discovered creatures from the New World like porcupines that was not known to Aristotle. And so he breaks with Aristotle's scholasticism by including these new creatures. And of course, in writing about these new creatures like porcupines, there is no Christian moralistic tradition to fit them in. There's no Greek mythology about them. They are literally new. And the other new thing that unfolds is a new approach to artistic expression about nature. From that fantastical drawings to a more realistic focus on animals and insects as they actually are. And my favorite among all of these artists is Albrecht Durer, who gave realistic depictions not just of animals, but also plants and plant communities down to their roots, as you can see in this depiction of a grassland, including accurate drawings where we can recognize the species of plants and grasses, and then the organisms that he depicts with all of their body parts, their structures of beetles, of owls, of the wings of rollers, and then my favorite, the hair. And this intensely realistic, detailed depiction of every hair on this hair. That's the difference with Durer, and that's the Renaissance difference as realism in natural history becomes the goal. That realism extends to botany as well. Looking at animals and the collection around those animals is matched in terms of this new herbal, going beyond the medieval herbals. And the most famous of these is Leonhard Fuchs' great notable commentary on the history of plants, and then his new herbal published in 1543. And what's different with Fuchs is this accurate and detailed woodcuts, in his case, showing plants, showing mandrake now stripped of its mythological characteristics, depicting the roots much more accurately, not as little humans, but as twisted plant parts below ground, and then including new plants from the New World like chiles. This attempt at a complete account of botany, much like Geisner's complete account of animals, that's what's depicted in the New Herbal of 1543. Who were doing this? Well, these key figures like Hooke and Geisner and Durer, but then those naturalists, self-identified as such, emerge in the early 1600s as a group out of Umbria in Italy. They called themselves the Linnaeans. They were the transition to the scientific revolution of Copernicus and Galileo and Kepler, but they were focused back on the Earth. They were named after the sharp-eyed lynx and Linnaeus, the keen-sighted pilot of the Argonauts. They were founded in 1603 by the 18-year-old Prince Federico Sessi, and they were the first true scientific academy, as we would call them. Now, they didn't see themselves as scientists, they were naturalists. They aimed at understanding all natural sciences through a method of research based on observation, experiment, and inductive method. Their goal was to penetrate the secrets of nature, observing both microscopic and macroscopic levels. They were able to do that because Galileo became a member of that academy, and he shared his discoveries in the heavens through his telescope, and Linnaeans could turn their gaze back to Earth and use those same lenses to magnify what they were looking at. Initially, Sensei and the Linnaeans toured the hilly countryside around his family's small castle in southern Umbria, and they gathered specimens that were then drawn by professional draftsmen. They also later included specimens from China and the Americas as they worked over 27 years. Their history is well recounted in the wonderful book by David Friedberg, The Eye of the Lynx, with many, many beautiful artworks that they produced. As he says in the book, Friedberg points out that the Linnaeans had made a deep investment in the worth of appearance by creating their extraordinary visual archives of nature. They included 2,000 studies of fungi, plants, mosses, lichens. Among them were the earliest surviving drawings ever made with the aid of a microscope. And they used that microscope to magnify to see the parts of mushrooms. These magnified drawings of fungi observed with extraordinary closeness and intensity represent the beginning of modern mycology. But through all of this work at looking at particulars and then looking at the parts of those organisms, Sessi realized, it dawned on him, as Friedberg says, that the drawings, with their exquisite attention to detail, texture, color, the unique particularity of each specimen, were preventing the Lycians from grasping the underlying order of things. And here was the difficulty with the realism of the Renaissance, because detail, texture, color, unique particularity didn't allow for the underlying order of things, recognizing the connections between these things and then classifying those relationships. It revealed a problem to be solved. Progress in natural history, as in other sciences, would come through establishing relationships, not by just collecting archives of illustrations. So it sets the stage in the Renaissance for the scientific revolution, the need to find order among all of the particulars. And the need was to find order not just in the macroscopic world, because what the microscope did was reveal a microscopic world. And this was a new world. No one had seen this before. The first great insight at that microscopic level was revealed by Robert Hooke. And his reputation in the history of biology is largely rests on his great work, Micrographia, published in 1665, still in print, still available to buy on Amazon. Go get it. He devised a compound microscope, a clunky kind of thing, based on Galileo's telescope, and an illumination system that allowed him to observe the parts of animals like fleas and the eyes of flies and the parts of ants. But it was when he turned his microscope to sliced sections of plants, in particular a sliced section of cork, that a structure to the new botanical world was revealed to him. For as he says, I could exceedingly plainly perceive it to be all perforated and porous, much like a honeycomb, but that the pores of it were not regular. These pores, or cells, were indeed the first microscopical pores I ever saw, and perhaps that were ever seen, for I had not met any writer or person that had made any mention of them before this. What Hooke had discovered were plant cells. More precisely, what Hooke saw were the cell walls in cork tissue. And he coined the term cells, box-like cells of cork, because they reminded him of the cells of a monastery. Hooke began to reveal a microscopic new world. But it took another character with another type of microscope to reveal the true wonder of that microscopic world. For it was Leeuwenhoek, with his very simplified microscope, that revealed not only plant structures, but that there was a living world out there. For Leeuwenhoek was the first to see bacteria. He took a drop of water, he applied his microscope to it, and as he says, looking at this water, the motion of most of these animalcules was so swift and so various, upwards, downwards, and roundabout, that 'twas wonderful to see. He's the first to see microbial populations alive in water. He revealed literally the natural history of this new microcosmos to match the macrocosmos. His magnification of 275 times allowed a resolution approaching 1 micron and revealed that in a drop of water there was a whole living world to be found. So the stage is set, both at the macroscopic and the microscopic levels, to understand a natural history that was far more complex than anything Aristotle imagined. And all of this comes at a time of the scientific revolution, the revolution that begins with Copernicus in 1543, where the Earth is decentered from the center of the universe, and now the sun takes over, culminating, as I talked about last month, in the application of mathematics to natural philosophy that Newton showed with his Principia Mathematica. And at the center of all of this is a transformation of knowledge. A transformation that begins with empirical investigation, that's championed by Francis Bacon, who hopes that empirical investigation will smash old ideas of natural philosophy and lead to a greater understanding of literally a new world, both macro level and micro level. And it was the belief then that new knowledge was possible that set aside these characters in the scientific revolution. David Wooten argues in his book, The Invention of Science, the dramatic success of the new science in explaining the natural world promotes this natural philosophy as an independent authority of challenging the old theological philosophy and constructing a new worldview. Gone is the belief that experience is a great teacher, and that experience focusing on learning from the past, from Aristotle in particular, to experience is actually teaching you that what other people know is wrong. It is experience in this sense. Experience is a path to discovery that was scarcely recognized before the discovery of America. Now, by scarcely recognized, he gives some concession to the fact that this was a process of emergence of a new practice of learning, both in natural philosophy and natural history, that we've now detailed, coming from Aristotle through medieval times to the Renaissance. It was a revolution in tools for doing that, both in logic and mathematics, and in the tools to see the world itself, the telescope and the microscope. With all of that new knowledge, then, comes the need to sort it out. Classification of all of this broad, emerging new knowledge of new worlds. And a key figure in that was John Ray. And John Ray, this Englishman who focused his work on plants and his natural history of plants, was a first step towards modern taxonomy, because Ray rejected the system of dichotomous division, mineral, plant, animal, human, that we inherited from Aristotle. Aristotle bringing a preconceived either-or type of system. Instead, Ray argued for classification of plants according to perceived similarities and differences emerging from observation. And Ray's system then began with the division in plants between the imperfect or lower plants, cryptogams, with the perfect or higher plants that reproduce through seeds. He divided seed plants by morphology, trees, shrubs, subshrubs, herbaceous plants, and then he lastly grouped them by common characteristics. One of those characteristics that was unique with Ray, this was the first person to divide flowering plants between monocots and dicots as they emerged from seeds. Ray classified plants by overall morphology, and so his focus on total morphology to classify organisms sets the stage for subsequent taxonomies. The classification in his 1682 book draws on flowers, seeds, fruits, and roots. Instead of a single feature, he attempted to base his systems of classification on all the structural characteristics, including internal anatomy. And he can apply this to animals as well, looking at the importance of lungs and cardiac structure. He effectively established the class called mammals. He divided insects according to the presence or absence of metamorphosis. He's looking at life cycles then with those organisms. This method produces a more natural system than the artificial systems based on one feature alone. It expressed also the similarities between species more fully. In fact, he's the first to give us a biological definition of the term species. He says, no surer criterion for determining species has occurred to me than the distinguishing features that perpetuate themselves in propagation from seed. Thus, no matter what variations occur in the individuals or the species, if they spring from the seed of one and the same plant, they are accidental variations, not such as to distinguish a species. Animals, likewise, preserve their distinct species permanently. One species never springs from the seed of another, nor vice versa. But what remains for Ray is that question then, how do new species come into being? And his answer, being a minister, is quite simply God. For Ray was also a promoter and believer in what he called natural theology and the argument from design, as it gets called in the 19th century. The argument from design asserts that the perceived evidence of deliberate design in the natural world demonstrates the necessity of an intelligent creator. Ray believed that an empirical study of nature revealed divine order and design in the world, and that the wisdom and power of God could be understood by studying his creation, the natural world. There is for a free man, Ray writes, no occupation more worthy and delightful than to contemplate the beauteous works of nature and honor the infinite wisdom and goodness of God. Because the study of nature for Ray and his natural theology reveals the wisdom of God manifest in the works of creation, the title of his 1691 work. This was his most popular and influential book. It argued that the correlation of form and function in organic nature demonstrates the necessity of an omniscient creator. However, in tension with this, Ray still supported scientific empiricism against the deductive rationalism of the scholastics. He cautioned against blind acceptance of authority. Let us not suffice to be book-learned, to read what others have written, and to take upon trust more falsehood than truth, but let us ourselves examine things as we have opportunity and converse with nature as well with books. And we'll see in subsequent lectures how this tension within Ray is resolved in the 19th century with the emergence of biology. The compatibility of natural theology with scientific biology is going to prove impossible with the emergence of evolutionary theory and Darwin. But that gets ahead of ourselves. Here the stage is set, and it's a stage that Humboldt knew, where natural theology exists in tension with scientific empiricism. Now, the sorting out in a scientific state culminates in the taxonomies of two characters. One of them is Carl Linnaeus, from whom we get the wonderful question, is it an animal, vegetable, or mineral, that we still use today in games of thought. But he used this question as a sorting mechanism for his great system of nature, and he applied then the technique, the modern scheme of binomial nomenclature, the genus-species structure that we still use. All of this is rooted in Linnaeus. His first edition of Systema Naturae was printed in 1735. He then returned to Sweden from Europe, from Western Europe, where he became a professor of botany at Uppsala. This folio volume was only 11 pages long, but it presented a hierarchical taxonomy of his three kingdoms of nature: minerals, plants, and animals. Each kingdom was subdivided into classes, orders, genera, species, and varieties. This hierarchy of taxonomy ranks replaced traditional systems of biological classification that were based on mutually exclusive divisions or dichotomies, the things we inherited from Aristotle. Here, this hierarchy of taxonomy is based on structural similarities of different organisms. For animals, he chose a different organ as the basis of 4 of 6 animal classes. Mammals had teeth, birds bills, fish fins, insects wings, amphibians limb structures in the way that they breathe. Do they have gills or lungs? Worms was his catch-all for all the leftover things. His term was for animals without a backbone that didn't fit elsewhere, and he used external characteristics to literally classify them, and creatures like worms themselves were in this category. But it was his work more specifically on plants, because he was a botanist as opposed to a zoologist, as we call them today. And his classification system for plants was a powerful innovation. Linnaeus became convinced of the idea that all organisms reproduce sexually. As a result, he expected each plant to possess male and female sexual organs, stamens and pistils, or as he called them, husbands and wives, to give the sexual narrative for all of nature. As he also put it, his sexual system of taxonomy used flower parts and its reproductive structures for taxonomy, and it focused then on the essential diagnostic characteristics that allowed a botanist in the field to classify the plant that he was or she was looking at. On this basis, he designated a simple system of distinctive characteristics to classify each plant. The number and position of stamens, or husbands as he called them, determined the class to which it belonged, whereas the number and position of pistils, or wives, determined the order. There you have a powerful system for beginning to sort out where a plant fits in this overall structure of nature. Now, this focus on sexual structures allows him to divide plants into classes by the number of male genitals or stamens. Monardria, 1 stamen, Diandria, 2 stamens, and then into orders by their pistils, the female genitals, the supporting structure. The calyx became a nuptial bed. Again, he's giving a sexual narrative to nature. This meant, of course, that some flowers had far more than a single male in that bed. Culturally, Linnaeus' system of sexual parts to classify plants was scandalous. The theologians were not happy. The churchmen were not happy. The sexual system, very Swedish, right, became popular because of its practicality, but it also was attacked because of its erotic connotations. But it was also attacked by other naturalists who felt that although it worked well for classifying plants, it failed to give a complete account of nature, in particular of zoology and the animal world that was becoming more and more diverse and more complex as naturalists circled the globe collecting more and more creatures beyond the old world. And it was the Comte de Buffon in France, this French naturalist, mathematician, cosmologist, and the author of a great encyclopedia of natural history that stretched to 36 volumes. It was Buffon that challenged Linnaeus's claim to a true system of nature. He criticized Linnaeus's taxonomical approach, in particular to the animal world, because Buffon noted that, for instance, despite similar environments, different regions have distinct plants and animals, a concept later known as Buffon's law, and it's considered to be the first principle of biogeography, and of course we'll learn that Humboldt takes that and truly applies it to a global understanding of biogeography that he'll detail in his books. Now, Buffon's approach then to classification was to look at the total morphology of classify organisms. In contrast to Linnaeus, Buffon was less concerned with simple identification, but more interested in vividly illustrating plenitude, diversity, and continuity of animal species across the world. Buffon insisted we must make use of all parts of the object for classification, not just sexual parts. We have to include internal anatomy, behavior, and then where they were in the world. In this sense, his approach was much more holistic, as we say today, than Linnaeus. These two approaches to taxonomy were what Humboldt inherited in his work. And these two figures are figures that he directly had to respond to and address. So natural history has traveled from Aristotle to Humboldt through observation and description into much more complex and detailed encyclopedias, much more robust and holistic collection, artists moving from fantastical depictions of animals to realistic botanical and zoological depictions of animals, all culminating in the classification and taxonomies of Linnaeus and Buffon. What has happened in terms of knowledge of nature? Well, it was Michel Foucault who looked back at this time period to write his first great philosophic work, The Order of Things. Because as Foucault recognized, and as we've been talking about in this lecture, the challenge is to bring order to the world that changes. Foucault, in his book, The Order of Things, focuses on three types of knowledge. Knowledge of life, as he calls it, knowledge of labor, and knowledge of language itself. And so Foucault, in The Order of Things, focuses on the history of biology, of economics, and of linguistics. And it's the first of these that's relevant to this talk. What Foucault argued is that all periods of history have possessed certain underlying epistemological assumptions that determine what was acceptable as, for example, scientific discourse. And we've seen this already, what Aristotle or Theophrastus understood as epistemology shifts in assumptions as we move through the medieval period to the Renaissance to the scientific revolution that brings modernity. Foucault develops the notion of episteme and argues that these conditions of discourse have changed over time from one period's episteme to another. Classical episteme was characterized by representation, ordering, identity, and difference. We've seen this too. Renaissance episteme, then, is characterized by resemblance and similitude as a focus on realism emerges. And all of this gives rise to the episteme of modernism, characterized by categorization and taxonomy. This was the scientific revolution. Foucault's argument here, I wholly agree with. The details of it are far more complex than this talk can detail, but this transition through different periods of time, this transition through different sets of assumptions, are what we've been detailing as well in these lectures. But what I most love about Foucault's book is his honesty about the origin of his insights to this focus on the order of things and the need to write such a book. And for Foucault, it all came out of a moment of laughter. And it's his accounting of this moment of laughter that I want to use to end this lecture. For his book, The Order of Things, has its origin in him reading another writer, Borges. And Borges' essay in his book, Other Inquisitions, on the analytic language of John Wilkins. Now, Wilkins was a writer from the time of the scientific revolution, and Borges focuses on the language that Wilkins was using. And in this essay, Borges dreams up or asserts the existence of a kind of Chinese encyclopedia of knowledge, the celestial emporium of benevolent knowledge. The celestial emporium of benevolent knowledge is a fictitious taxonomy of animals that he describes. And Foucault writes about it in this way. This book first arose out of a passage in Borges, out of the laughter that shattered as I read the passage all the familiar landmarks of my thought. Our thought that bears the stamp of our age and our geography, breaking up all the ordered surfaces and all the planes with which we are accustomed to tame the wild profusion of existing things, and continuing long afterwards to disturb and threaten with collapse our age-old distinction between the same and the other. It was a moment that Foucault had as he read Borges that made him laugh. And in that laughter, it made him realize that our assumptions about how nature is ordered, this distinction between the same and the other, is in a certain sense historically arbitrary. Foucault goes on to say, this passage in Borges quotes a certain German encyclopedia, a certain Chinese encyclopedia, in which it is written that animals are divided into A, belonging to the emperor, B, embalmed, C, tame, D, suckling pigs, E, sirens, F, fabulous, G, stray dogs, H, included in the present classification, I, frenzied, L, innumerable, K, drawn with a very fine camel hair brush, L, etc., M, having just broken the water pitcher, N, that from a long way off look like flies. Foucault goes on, in the wonderment of this taxonomy, the thing we apprehend in one great leap, the thing that, by means of the fable, is demonstrated as the exotic charm of another system of thought, is the limitation of our own, the stark impossibility of thinking that. And Borges concludes, there's no description of the universe that isn't arbitrary and conjectural for a simple reason. We don't know what the universe is. Humboldt will agree with both of these statements. Humboldt will take both of those seriously. Humboldt will try to incorporate into Humboldtian science those insights. And for this reason, we will be exploring in detail how those ideas influenced Humboldt in his work. The Humboldtian cosmos, then, is a vision of the unity of nature. And that cosmos is both ordered and beautiful. Unity and diversity, and of connection, resemblance, and order among created things most dissimilar in their form, one fair, harmonious whole is the cosmos for Humboldt. And it's on that background that we've detailed in these first two lectures that he asserts that claim. Join us for the next lecture, where we'll look at more background to Humboldt, the background of explorers going out, finding new worlds, and creating a new geography of nature.